In this video, we are going to have a look at function expression. Function expressions are another way of creating functions. In fact, we have already seen such methods of creating functions, but actually let me here explicitly say that there are three ways of creating functions. One is normal function declaration. So this declaration function is there, right? Second one is function expression, and the third one is function constructor, which we will see in the next video. Right now, let's have a look at function expression. So you might have observed that normal functions are declared like this, that is fine. And so for example, let's say there is a sum function, we pass two arguments and return a sum of that, that is fine. And if we print that is 5, that is fine. Now if we are creating arrow function, not this type of function, then we already know that we could do something like const sum is equal to something like this, right? A plus b, and this will also work fine. This will is not defined, yeah. So basically we forgot to pass a and b, yeah. So the point is that this will also work fine, but let's write the bigger syntax only, not implicit return. So this is same as this, okay. So this is working fine. Now we already saw that this way to create functions. Now see that this is a function declaration. In fact, this thing is when we declare arrow functions, actually this part of thing where we assigned something, this thing is called a function expression, and that's what we are covering here. It's a simple thing only, but just wanted to highlight here that here also sum becomes a variable, but it is a declaration block, and as a result of that declaration sum becomes a variable. But here you are explicitly creating a variable and assigning it to some expression, and that expression, for example, this sum can be anything, like let's say 5 plus 10 or 5 plus 2 plus 50, right? Now this thing is an expression, it is evaluated and its answer is assigned to sum. At the end you are having a semicolon, right? Because this is a statement and this is assignment and this is an expression which is evaluated and so this is declaration, and in contrast to this thing is an expression, okay. So you understand that, and here also, like at the end of the expression, any expression you should put at the end of any statement you should put semicolon. And since we are using statement, we are creating a expression based statement, and that's why it is preferable to put semicolon at the end. Note that here we are not putting semicolon. In fact, we should not put, right? Because that is a declaration. In declarations it is not required to put semicolon because that is not a statement. You understand that this is an expression, and that's why if you remember that then we had a term called IIFE, immediately invoked function expressions. So here also function expressions, you understand? So this function expression is actually that only. So when we did something like this, so for example, we created a function and immediately called it, and inside that we wrote something like this, then we meant that only, that this thing from here to here is a function expression which is invoked immediately, and that's why it was called immediately invoked function expression. In a similar fashion, you can also understand that this thing is a function expression. Expression is what? Expression is a piece of code which returns a value, which evaluates to some value. So for example, we already discussed the 2 plus 4. You can say that this is an expression. Why? Because 2 plus 4 gives us a value 6, right? Now what is this value? This value is of type number, right? Similarly, this whole thing is an expression, and what is this expression evaluates to? This expression evaluates to a function, okay. So now you understand. So just an idea, and if you remember, then we actually inside IIFE also we could use, instead of arrow function, we could have used sometimes when we used also function keyword. So we could also use something like this, and this will also work fine. If you print this, then let's say 1 2, then you see that 3 will be printed. Let's see. Yeah, so let's the multiple declarations of sum is there, so that is the issue. Anyways, so you can understand that this 3 is returned, and again if you like print a and b, then you get 1 2, and you can understand that this IIFE can also return a value. So for example, const x is equal to this thing, and then if you print, so this is like as good as a simply a function, right? So if you print x, then it will be 3. So that is fine. I just wanted to show you that a function expression can also be created from a function keyword. So all arrow functions are function expressions, so that is fine, right? But I wanted to say that function expression can also be created from function keyword, and that is what we are going to do here. So rather than this, we could also write const sum is equal to and a function keyword, and rest everything same, a comma b. So you can understand that earlier we had, and now here we should put a semicolon, because now this thing is a function expression. Okay, so here this was a function declaration, where as a result of this declaration a variable sum was created, which was a function. Here we are explicitly creating a variable and assigning it to a evaluated function expression. This function expression evaluated. Now you can see that this is a function named sum. This is a function, this is an anonymous function, this is an anonymous function, no name. But now sum is equal to this. When we do this, then sum is a variable which is a like name, which has been assigned this function. Okay, so here already the name was created, here anonymous function was created and given a name sum. Slight difference, but you just have to understand the semantics, because this is another way of creating function and this is another way of creating function, right? What is the difference? There is not much difference in terms of execution, but there is a very important difference in terms of hoisting. So if you remember earlier that we said that you know what, if you have something like this, then hoisting is not there, and if you have something like arrow function, then hoisting if you have something like this, then hoisting was there. If you had something like this, then hoisting was not there, arrow function, then hoisting was not there. You remember? Let me show you again. So a plus b, let's say ab, and this is an expression, that's why let's put a semicolon at the end. Okay, now so hoisting is what, that you could call that before declaration, but here you can see that, see here you are doing after, so it doesn't matter, you can obviously do that, right? After you can do that, but can you do that before? Can you do that before? Which means that I called it first and declared it later. Can I do that? You can see that it is giving me error that it cannot be done because of that, only that problem hoisting. But if you don't use function expression, if you use function declaration, right, then turns out that you can do that. You can call it first and declare it later, and then also it works. Why? Because the function declaration, for function declaration, hoisting is supported, which means that JavaScript parser will automatically take this piece of code and put it at the top. All the declarations that will put it at the top, and that's why this code still works even if it is. But since we now converted this function declaration to a function expression similar to arrow function, now this will again stop working. So hoisting only works for function declaration. It does not work for any form of function expression. Either it is of this form or this form, in any form it will not work, right? So if you are using this sort of function expressions, then you have to use only after declaration, because hoisting is not supported. And if you use after that, after declaration, then definitely it will work as expected. So yeah, that was the idea which I was saying, that once the function expression is there, then you can create it something like this, like arrow functions which we did earlier. You can create a function expression like this also. And we also mentioned that function expressions are not hoisted, which means that if you have a function created as like a function expression, not as a declaration, then you cannot hoist it. You cannot hoist it, and that's why if you try to access it before declaration, then if it will simply say that, yeah, you know what, it cannot access sum before its initialization. So yeah, that will be all. This was a small topic of function expression, just to confirm the syntax which we were using. Earlier we were using this syntax many times, but I did not clearly mention that this is another way of creating functions. Anyway, thus the two ways, the declaration way and the function expression way, are done. In the next video, we are going to see something called function constructor, which is a third way of creating a function.